Hi everybody. So we left class last on Tuesday with this equation, this v equals d over t equation, and I want to sort of talk to you a little bit more about how we actually go ahead and apply equations to physics problems. As I said on Tuesday, the most basic physics equation is v equals d over t, and you figured out how fast the car goes by figuring out how far it goes, dividing that by the time it took to travel, how far it went. And we call that a velocity. And the unit comes from just taking a displacement, which is meters, and a time, which is seconds, and dividing meters divided by seconds, and that gives you the unit for velocity, meters per second. So I kind of hope that makes a little bit of sense to you. And I'm sorry I don't have my stylus here, so I'm actually doing all this with my index finger here and no pen, so forgive me if it looks a little weird and if you hear tapping, that's just me tapping on my screen. But I want to sort of show you how we attack physics problems, at least in the beginning of the year. And it sort of has to do with this idea that we start out with the 5 kinematic quantities, the things that we want to know about how things are moving, and those are the velocities that they are moving, and I'm actually going to put 2 of them in, and you'll understand why in a second. Acceleration, time, and distance, or displacement. And the idea is you want to try and fill out as much of the information as you can about those 5 quantities, about every problem that we can deal with. Now, there are 2 velocities because sometimes we deal with objects that are moving in constant velocity that don't change their speed. But sometimes we do look at things that are moving in non-constant velocity, or where they're accelerating, where we have a beginning speed, or what we call an initial velocity, a VI, and a final velocity, or a VF, which is the speed that they're going at the end of the time that we're looking at them. So you'll see this as we go throughout the year, that every single kinematics problem I have, I start with these 5 things, VI, VF, A, T, D. And we're going to employ this over a few problems. I just want to sort of give you a crash course in how we use the equations. And you're going to get 3 new equations today or this evening that I hope that you write down and put on your physics, your equation sheet, besides just this one. Okay, so let's talk about this. Let's take a look at this problem. A ball rolls along a table taking 3 seconds to travel 6 meters. Calculate the ball's velocity. So, we know a few things. We know that the ball is moving for 3 seconds. That sounds like a time. And we know that the ball goes 6 meters, and that is a displacement. And I'm telling you to calculate the velocity, and I don't really tell you that there's an acceleration. So we can make the assumption, unless I ask you for an acceleration, or unless I tell you that there's an acceleration, you can assume that the acceleration is 0 meters per second squared. And that meters per second squared is a weird label, a weird unit, and we're going to try and unpack that in the next couple of days. But for now, just go with it. The accelerations are in meters per second squared. So we're looking for a velocity with no acceleration, which means we're going to be using this equation, v equals d over t, and because there's no acceleration, there is no vi or vf, there is just the one constant velocity. So there's no VI or VF in this particular scenario. There is just a velocity. And we know that the acceleration is 0 meters per second squared because we kind of assume by looking around the problem that there's no acceleration. We know the time is 3 seconds, and we know the displacement is 6 meters. And we're going to use the equation, v equals d over t, and we're going to calculate v equals 6 over 3. 6 over 3, last time I checked, is 2 meters per second. So 6 meters and 3 seconds. And you just do the dividing. 6 divided by 3 is 2. So that's your first little foray into a real-life chemistry problem. Or, I'm sorry, chemistry problem. It's a physics problem. So we can move on, and I want to introduce you to another type of equation. And this is a little more, it's a little trickier. It's a little more to think about. And I've sort of written these with the idea of using a particular equation as I'm writing them. So the next equation I want to introduce you to is VF equals VI plus AT. Final velocity is initial velocity plus the acceleration times the time. So this equation is what you use when you don't have a displacement to deal with. So I'm going to make a chart again. VI, VF, A, T, D, F, there you go. A car starts at rest and accelerates at 3 meters per second squared. How fast is it going at the end of 5 seconds? So we are given some information and we are asked to find some other information, and there's some other stuff that we just don't have. Like I said here, we don't have a displacement. This equation, you don't need a displacement. So displacement is kind of off the books for me. I don't care about it. A car starts at rest. Well, how fast are you going if you're at rest? 0 meters per second. And it accelerates at 3 meters per second squared. Okay, so that's an acceleration. And we're looking for how fast we're going at the end of 5 seconds. Hold on.
Please pardon the interruption.
Thank you, Mr. McEnaugh. So back to what I was saying. We have some quantities within the problem that we know, and we also are missing a displacement that isn't even mentioned, and they're not asking for it. Me, are not asking for it. But what we do have is an initial velocity that's at rest, and we know that's 0 meters per second. And we have a final velocity that we're looking for, so we don't know what that is. We know the acceleration is 3 meters per second squared, and we know the time is 5 seconds. Okay? So we can use this equation. We'll talk about how to choose the proper equation in a little bit, but we can use this equation to do a little bit of algebra and figure out that final velocity. So VI is 0 plus the acceleration is 3 times the time is 5. And we're assuming it's all in the positive direction because in the problem it's a positive 3. So 5 times 3 is 15. Our final velocity is going to be 15 meters per second because 15 plus 0 is 15. So that's sort of how we start doing and teasing out different physics issues. We can make a prediction. If a car starts at rest and goes 3 meters per second squared for 5 seconds, it's going to end up going 15 meters per second. It's going to go faster and faster and faster. Another equation I'd like to give you is this one, VF squared equals VI squared plus 2AD. This is an equation that you can use when you don't have a time. If you notice here, we have a velocity, an acceleration, and a displacement, but no time. So we're going to set ourselves up again, VI, VF, A, T, D, and we can now look at the problem. A boat begins traveling at 25 meters per second and begins to slow down over the course of 200 meters until it eventually stops. Calculate the acceleration of the boat. So we're looking for the A. Okay? We know the VI is 25 meters per second because it's going 25 meters per second. I know it's a velocity because it's meters per second. And it slows down over the course of 200 meters, so that's a D, until it eventually stops. That is a VF. Calculate the acceleration. So what they don't ask for and they don't care about is time. But I know my VI is 25 meters per second. I know my VF is 0 meters per second. And I know my displacement is 200 meters. And I'm looking for my acceleration. Now I'm going to use this equation, VF squared equals VI squared plus 2AD. And I'm going to try and squeeze it over on the right side of the screen, but if I don't, we'll move things around. So VF squared is 0 squared equals 25 squared plus 2 times A, which we're looking for, times 200. Oh, I can't believe I got that all to fit in. So now it's just time to pull out your calculator and start figuring some stuff out. 0 squared is still going to be 0. 25 squared is actually 625 plus 2 times A times 200. Okay? So now the question is, what do we do? So algebraically, we have, and this is why I asked you about all those literal equations in the a couple weeks ago. The next thing we're going to do is we're going to isolate the 2A times 200 and get rid of the 625. And the way we do that is subtract 625 from both sides. So 0 minus 625 is negative 625. 625 minus 625 is 0. but we're going to be left with 2 times a times 200. I hope this is making sense. So the next thing I'm going to do is multiply 2 times 200, and that's going to be 400 times a, and that's negative 625. So now the next question is, well, what do I do with that 400 to get rid of it? And we're going to divide both sides by that 400. Divided by 400. And extend page, because I need more room. So negative 625 divided by 400 is negative 1.5625 equals a. And what that means is we are accelerating in the negative direction, 1.5625 meters per second squared. Sorry. And that is your answer for what's the acceleration of that boat. Algebraically, I hope it makes sense. And as we talk more about physics, I believe you're going to be a little more comfortable using these equations, but also these quantities. The last one I want to show you is d equals VIT plus 1/2 AT squared. And this is a good one when you're missing the VF, because there's no VF in the equation. So again, we're going to start, and I'm going to have to slide back and forth here. VI, VF, AT, D. A car is already moving at 20 meters per second, so that's a VI, and accelerates at 3 meters per second squared, that's an A, to pass another car. If the maneuver takes 5 seconds, that's a time, to accomplish how far, that's a displacement, does the car travel in that time. So they're asking us for the displacement, the D. They don't give us the VF, but we know the VI, and that is 20, positive. We know the A is positive 3 meters per second. And we know the time is 5 seconds. Equals, equals, and equals. Now we're looking for what that D is going to be. So D equals VIT plus 1/2 AT squared. D equals 20. All I'm doing is plugging in from this stuff into the equation. 20 is VI, T is 5, plus 1/2 A, which is 3, times 5 squared. So 20 times 5, last time I checked, is 100, plus 1/2 of 3 times 5 squared. So 5 squared, I'm going to do this in a calculator. I'm going to start with PEMDAS. 5 squared is 25, times 3 is 75, times 1/2 is 37.5. So 37.5. So D is 100 plus 37.5, which is 137.5 meters. And that is how you attack a question when you need to use D equals VIT plus 1/2 AT squared. In class, we're going to go over how to decide which equation you want to use. But for right now, I'm hoping that this just sort of, you've gotten the 3 equations written down. If you didn't, go back and get them. And we'll pick this up in class on Thursday. I hope that helped, and enjoy the rest of your night.